The truth about NASA's new space capsule. Have you ever wondered about the incredible advancements propelling us deeper into the mysteries of space? Picture a cutting-edge spacecraft, the NASA Starliner, also known as CST-100, soaring through the vast expanse of the universe, unlocking new possibilities for human space exploration. This stellar capsule is not just another invention, it's a game-changer, a beacon of innovation propelling us further than ever before. It's also a symbol of NASA's unwavering commitment to safe, reliable, and efficient human spaceflight. Imagine astronauts boarding this spacecraft, ready to embark on daring missions to the International Space Station and beyond. It's a journey that pushes the boundaries of our cosmic exploration. But how did this extraordinary venture begin? To comprehend the Starliner's significance, we must rewind to a pivotal moment when NASA set a course for a bold new revolution in human spaceflight. Before we dive deeper, quickly subscribe to our channel and turn on your notification bell so you don't miss out on any of our videos. In the post-space shuttle era, NASA sought to restore its ability to send astronauts into space, particularly to the International Space Station, recognizing the importance of fostering partnerships with commercial spaceflight companies. NASA initiated the Commercial Group program, which aimed to develop spacecraft to transport astronauts to low Earth orbit. The Commercial Group, initiated in 2010, marked a significant shift in NASA's ability to space exploration rather than exclusively depending on Russia for trips to outer space, which was not only expensive, but risky from a geopolitical point of view. The agency recognized the potential of collaborating with commercial entities to reduce cost, stimulate innovation, and expedite the development of transport astronauts to and from the ISS. Companies would compete with one another to create the most creative, economical, and safe solution to transport crew members to the International Space Station, and NASA would award contracts to the winners. Fast forward to 2014, and following an extensive bidding procedure, NASA awarded Boeing a $4.2 billion contract to develop the CST-100 Starliner spacecraft and carry out 6 missions to the International Space Station. Additionally, Elon Musk's SpaceX was awarded a $2.6 billion contract to create the Crew Dragon capsule and carry out 6 independent missions. With 2 private companies in the mix, the assumption was that healthy competition would result in a better product, delivered quicker and more efficiently than if NASA developed it themselves, and having 2 companies on board prevented monopoly. Sadly, the domestic space competition that NASA had anticipated turned out to be significantly more one-sided than they had anticipated. It was originally intended for the first crewed test flight test to take place in 2017. On May 19, 2022, Boeing completed the orbital flight test following a lengthy development process marked by several delays. The crewed flight test has been postponed until at least mid-April 2024 as of October 12, 2023. Before Starliner enters operational service with the Starliner 1 mission, this test flight is anticipated to be the final one. In contrast, SpaceX carried out its first unrefined mission in 2020. Now let's take a deeper look inside this cosmic vessel. Boeing's CST-100 Starliner stands as a testament to human ingenuity and top-notch engineering. Starliner has an Apollo-like design with conical sides, a shape that's stable when the capsule is plummeting at high speed through the Earth's atmosphere. What sets it apart? It had more impressive autonomy than either the Apollo spacecraft or the Space Shuttle. Starliner expertly docks with the International Space Station with little to no intervention from astronauts. Safety is a priority too. Unlike the Space Shuttle, Starliner has a nifty escape system that can propel the crew away from its rocket if an emergency occurs during launch. The internal core of the crew module, called the pressure vessel, is manufactured in 2 halves. Each half is made from a single piece of metal, rather than from different pieces welded together. Less welding means fewer chances of structural hiccups. After the 2 halves of the vessel are sealed together, the sloping sides are enclosed within a protective envelope called the back shell. Blankets made of silica and woven glass cover the outside, but areas that receive more heating on re-entry are shielded with ceramic tiles, like those used on a space shuttle. The spacecraft consists of a reusable crew capsule and an expendable service module. The capsule has a diameter of 4.56 meters, which is slightly larger than the Apollo command module and SpaceX Dragon 2, but smaller than the Orion capsule. The Boeing Starliner can hold a crew of up to 7 people and can remain docked to the ISS for up to 7 months. The The Starliner is designed to be reusable for up to 10 missions. NASA missions will take between 4 and 5 passengers per flight, swapping the seats for extra cargo storage. If the 5th seat is vacant, Boeing has the option to sell it to a space tourist or carry an astronaut from another country. The control console has 2 display screens. While SpaceX opted for touchscreens in its Crew Dragon vehicle, Boeing went for the traditional approach of switches and buttons. Because most spacecraft operations are automated, crew members won't have to engage much with the vehicle. But if for any reason they have to assume manual control, the traditional layout gives them everything they need to fly the ship. During liftoff, ascent, and re-entry, crew members wear the Boeing Blue flight suit, designed to protect them from a depressurization event in which air is lost from the capsule. The company says it is 40% lighter and more flexible than earlier generations of spacesuits. The shoes are more like cross-trainers than heavy boots, and the gloves are touchscreen sensitive, so the crew can use tablet computers during flight. Unlike other designs, this one features a flexible hood and visor instead of a hard helmet. The idea was prompted by Ferguson's experience of returning to Earth in the bulky suits used on the shuttle. After 2 weeks in microgravity, Ferguson said the metal ring where the helmet attached would push down on his shoulders, causing them to ache. Starliner launches from Cape Canaveral Space Force Station on the Atlas V. The 58-meter-tall Atlas is one of the most reliable rockets available and launches from Florida's Cape Canaveral Air Force Station. After 31 minutes after liftoff, Starliner, having now separated from the upper stage of its rocket, fires 4 thrusters to put itself in the right orbit. It then embarks on a 24-hour orbital chase to catch up with the space station for rendezvous and docking. After spotting the ISS as a bright point of light with its onboard cameras, Starliner maneuvers closer to the orbiting outpost. It pauses outside a 200-meter keep-out sphere until flight controllers clear it to begin the autonomous docking process. The onboard computers analyze data from sensors on the outside of the craft. The information informs an intricate orbital ballet that occurs as hundreds of finely tuned thruster firings guide Starliner into the dock. Starliner is designed to stay in orbit for around 7 months. The Starliner offers a reliable means of transporting astronauts to and from ISS safely and efficiently. This not only reduces reliance on the Russian Soyuz spacecraft, but also enhances NASA's ability to conduct a variety of missions on the ISS scientific research and technology development. However, Starliner isn't merely a celestial taxi service, it also facilitates scientific research and technology in space. Astronauts aboard the Starliner have the opportunity to conduct experiments, gather data, and advance our understanding of various scientific disciplines. This contributes to NASA's overarching goal of expanding scientific knowledge in space and its applications to Earth's challenges and setbacks. The development and deployment of a spacecraft as advanced as the CST-100 Starliner are not without their challenges and setbacks. Throughout its development, the Starliner has had its share of bumps, technical glitches, and mission delays. Throughout the program, technical challenges have arisen requiring innovative solutions and thorough testing. Some of these challenges included issues with the spacecraft propulsion system software and parachute deployment. These problems were not unlike those SpaceX experienced in 2013 with their similarly new Dragon capsule during the CRS-2 mission, when 3 of the 4 thrusters failed, forcing docking with the ISS to be delayed by 24 hours. Both companies saw thruster problems on the ground as well. In 2018, malfunctioning valves caused fuel leaks and a fire which damaged part of the test capsule during a launch abort test. A year later, a SpaceX Crew Dragon capsule was destroyed in an explosion following a hot fire test of thrusters used in the event of an abort on a launch pad. Each company also struggled to develop the required parachute systems. According to a 2019 report from NASA's Inspector General's office, concerns grew about NASA's reliance on Russia as delays from SpaceX and Boeing stretched to 4 years. When SpaceX changed its initial plan from propulsively landing on dry land to focusing on splashdown in the Gulf of Mexico, the 4 lightweight parachutes needed to be redesigned. This required another 15 ground tests, which uncovered more problems. Boeing also experienced problems when one of the 3 parachutes failed to open during a Starliner pad abort test in 2019. The problem was later traced back to a simple pin that was overlooked by the closeout crew. Fast forward to 2023, Boeing also had been working towards a July 21st launch to send 2 NASA astronauts to the ISS. This mission has been delayed several times, and this latest setback is concerning. Just weeks before the launch attempt, Boeing managers determined that adhesive tape used to wrap and protect hundreds of yards of wiring inside the capsule could be flammable under certain circumstances. In addition, the lines connecting the capsule to its trio of parachutes were not as strong as Boeing believed. During landing, it's possible that some of the lines could have snapped, potentially endangering the crew. Starliner is designed to land with just 2 parachutes, but if one parachute failed, the others could have 2. For all of these reasons, Boeing Vice President and Starliner Program Manager Mark Nappy told reporters the company was standing down. Safety is always our top priority, and that drives this decision. Nappy says they'll take the next several weeks to investigate the design issues and come up with potential solutions. But Boeing remains steadfast in its commitment to improvement, despite trailing a bit behind schedule. CST-100 Starliner represents a remarkable chapter in the history of human spaceflight. Even with the occasional setback, it stands as a symbol of the power of collaboration between government agencies and commercial entities for the greater cosmic good as it continues to evolve and fulfill its mission objective. It serves as a symbol of the enduring human spirit to venture beyond the boundaries of our world. The truth about NASA's new space capsule, the Starliner, is a testament to our unwavering commitment to pushing the boundaries of space exploration and seeking answers to the profound questions that await us among the stars. What do you think? Let us know in the comments section, and don't forget to hit the subscribe button.